right-angled trigonometry, finding angles. So we've got a couple of uses of trigonometry. We can find unknown sides when we can't easily measure them. We can also, if we have two sides of a right-angled triangle, use those to find any unknown angle. We might get a couple of questions that look like this, and this is just making sure that we can solve our equation to find theta. You'll remember I said that you can always get sine, cos or tan of a ratio of an angle, So say we want sine of 30 degrees, we do sine 30. And that gets the ratio of 1/2, which says that opposite over adjacent will give us 1/2 for any right-angled triangle with 30 degrees. The opposite of that is if I know that the ratio is sine of the angle is 1/2, the angle must be 30 degrees. And we get that by doing inverse sine of the ratio that we know, which is 1/2 or 1/2, and we'll get 30 degrees. So inverse, this little sign with the -1, says the opposite of sine. I know the ratio, please tell me the angle that goes with it. Another way of thinking about it, I've got tan of the angle equals 0.3. I just want to find the angle, theta. This is an equation. When I'm solving an equation, I do the opposite of whatever I want to remove to both sides. So tan of the angle is 0.3. I want the angle on its own, so I need to do the opposite of tan to both sides. That will cancel this out here and just leave me with the angle. And the opposite of tan is inverse tan, or tan to the power -1. And I'm going to do inverse tan 0.3, second function tan 0.3, and my angle to the nearest degree, is usually how we give it, will be 17 degrees. So theta equals 17 degrees. So when I'm asked to find theta, I know I'm going to use inverse of the ratio, and of course I'll give my answer to the nearest degree. So to solve this one, cos theta equals 0.635. So theta equals inverse cos 0.635. Inverse cos 0.635. The angle is 51 degrees. Now that's just checking that we understand how to use inverse of the trig ratios, knowing the ratio, asking for the angle. The type of question we'd usually have to solve is this. Being asked to find an unknown angle, you will need two sides of a right-angled triangle. The steps are the same. So almost all trig problems that we're going to have to solve, you're going to start by labeling the sides. Oops, label, can't write today, sides. Here's my angle, I have the adjacent and the hypotenuse. Choose and write your ratio. I've got adjacent and hypotenuse. I will write cos theta equals A over H. Don't forget to write in theta. That's the thing that is most likely to mess people up. The third step, as always, can't even draw a star today, I don't know, is substitute values. Cos, we don't know the angle, is 3.1 over 5.2. Now, that's a ratio. You don't need to simplify it. You don't need to divide it out. We just need the angle on its own, theta, which means we do inverse cos to each side, cancelling out cos, inverse cos of that ratio, and you can enter that straight into your calculator. Second function, cos 3.1 over 5.2, close your bracket, and the angle is 53 degrees. And my fourth step is to solve with units. And I just ran out of ink, so that's amazing timing. So the steps are the same for finding an unknown side and finding an unknown angle. And the only thing you need to remember is what your strategy is when you come to solve to find the unknown.